I'm going to record this. I forgot to record from the beginning.
Yeah. Oh, okay. I'm not able to place PPT over here in the chat box.
We can
Uh,
share it later. We'll share
Later.
a folder where
Fine.
they can. So you just
That's yeah. Perfect.
open the PPT and then you can.
Perfect. Okay. Okay. Yeah. Good evening, everyone. We are here to share our knowledge and the experience with the data analysis with the Python. This the conversation or the meeting is organized only for working adult who really wants to jump into data analysis. You may be having some experience in other areas and want to move to data analysis, for which this course will be beneficial, and this course will give you the fundamentals how you should start your career in data analysis. As Indra said, it is organized by Kids Tech Charitable Trust. We are going to have this discussion for next 6 to 7 weeks of time. The first 2 weeks will cover the fundamentals of data analysis and the statistical test. You'll be today next 90 minutes. You'll be introduced to what is data and how the data analysis is being carried out, and knowing or given the fundamentals of data analysis, you will be moving to statistical analysis in the following week, next Thursday, where you'll be learning about why the statistical analysis, statistical test is to be conducted, how to interpret your result. Because this is a basic thing you must know when you are moving to data analysis. Then following week, third and fourth week, we will introduce you the Python fundamentals and the programming concept. And once you learn the preliminary part of Python codings, then you can move to the exploratory data analysis in the following week, next 2 weeks, okay? Third part of our session, which will be the data handling, how you can handle the data and do some analysis, exploratory data analysis using pandas and NumPy. You'll be able to plot your data in different forms and able to do the transform the data and load the data. So with this one, this session, this part of discussion will be completed. After this one, maybe we will start the intermediate level of Python coding, where you will be learning the prediction model and other things followed. I'm Ilango, going to start today the session. Today's session, as I said, it will be the understanding of data and the classification of the data, and the next week will be the statistical test. Very important thing for any organization is to have a productivity, to have high profit, and to have customer satisfaction. So whoever is investing some money, they expect the return on their investment. So they have to take up some decisions to get production and productivity. So how to take the decisions? Who will take the decision? This is the query over here. Whether the person who is in the higher position takes the decision, and what form of decision it would be, or what basis he will take the decision. So these are the few things every one should understand. So what we do is we do the business analytics with different methods, different tools, but who is taking the decision is important. Usually in the earlier olden days, what companies did is they used hypo strategy, where the person paid high salary is used to take the decision. But these days, all the companies are moved towards the data-driven decision making, where what we do is we will be working on evidences. We are working on evidence-based decision making. What we do is we collect the data and do some analysis to understand the data and interpret our data for the decision making. So all we need is to know the cause and effect relationship between the parameters or the features involved in the data. What I try to say here is you may be having hundreds of data, but all the data may not be having mutual relationship, or your aim, your goal, that particular data will be having some good correlations or relationship with the few features of your data. So being the data analyst, you have to identify the relationship between the parameters, a relationship between the parameters, dependent parameters and the independent parameters. So that is very important for us. So with this one, with this kind of approach, we'll be able to have evidence-based decision making. Okay, this is required for all the companies, not only the big companies, even for the small, medium scale industries as well, or small scale industries as well. For example, you just consider Amazon. Amazon, they are doing e-commerce, but they used to have a fraudulent transactions across the globe. So they have to identify this one and sort out this problem. They have to take the decision on this kind of fraud transactions. So how to take the decisions? So they have to collect the data and find out the root cause and the relationship between the variables so that they can take the right decision to get the things done. So this is very much important for the data analysis. So this is what I explained you, Hippo-led decisions, where the senior person, the highest paid person's decision is the final. So he may discuss with the people, other people involved in the business, but sometimes he may involve the other people, or sometimes he may not involve the other peoples. So this is how it was. So this concept, the strategy, we are not following these days, and we have moved to data-driven decision making, where as I said, is what we do is we set our goal. Based on the goal, we collect the data and we go for the evidence. I mean, we do analysis to find out the interpret the result or find the evidence. Okay. Now, being the data analyst, you are going to do data analytics. So when you are planning to do data analytics, what are the different tasks you have to do? This is important. For example, you may be getting the data from various sources. Okay, I just put a slide over here. On the right, you can see a picture where you can see the description of data analysis process for banking application. Say, what we do is we get data from transaction records, we get data from the customers, we get data from credit systems, we get data from ATMs or other online transactions. So we get plenty of data from various sources, but these data cannot be used immediately or cannot be taken for processing immediately, because these are the raw data. These raw data may not be in the right form or the standard form. So being the analyst, you have to identify the data required for your analysis, and then you have to remove or clean your data. Remove your data in the form of, like, some data may be duplicated, some data may be empty. So we do not know how it is. So we have to remove the unwanted data and duplicate data, clean the data, or sometimes be replaced with the missing data with something else, mean or something. And we do some standardization as well. The standardization is very much important to bring out the right solution for your analysis. So after completing the standardization, you may go for integration, data integration, where you'll be combining different data into one form. And once everything is perfectly done, then you will upload, you will store the data in somewhere. It could be cloud or your local computer or data lake or anywhere. So once you store all these things, then you can do some analysis. So being the data analyst, the first part is ETL process. So ETL process comprises of extract, transform, loading. So once this is done, then you can go for you can go for analysis. That analysis could be descriptive analysis, predictive analysis, or the prescriptive analysis. That is what I'm going to discuss next. So in this session, I mean the following week, what we are going to learn is, after I introduce you data and the statistical test, I'll be explaining you how the ETL process is to be done. I mean, how this the basic fundamental ETL process is to be done, and how interpretations, I mean analysis, the descriptive analysis is to be conducted, exploratory data analysis to be conducted. So this is our learning outcome for this. All good. So I'm as I said, this is the process. Okay, data driven analytic flow. So as I said, you will frame the decision problem. You will set the goal, what you want. Then you will collect the data from different sources. Then you will do some cleaning operations, or you prepare your data for your own analysis. Then everything is done. Then you will go for analysis. You do descriptive analysis, testing, and all these things, and then you will build your model. You build your model, data model. It can be for any. It is based on your objective. So once the built data model is built and tested, then you can deploy your model into your real-time system. So this is the common data-driven analytics workflow. Okay, coming to data science. Why the data science is required, or data analysis is required, and how do we do data analytics? It is everywhere. Even in our family itself, we do this kind of decision making. We do some kind of data analysis. Okay, so with our past data, what we do is we have some learning, we have some past input. So based on the past input and the learning data, we do our decision making, we do analysis and do some decisions, take decisions. Okay, so what the data analyst or the person is doing is, when he is given a problem, he will identify the right statistical model or the machine learning model to develop the particular data model. Coming to this, I explain you again. What is statistical model? What is the statistical test? Or what is machine learning model? You are planning to develop some data model for the data you have with you. Okay. For example, if your objective is to identify or classify the pregnant people and non-pregnant people. Okay, so you have the data of the people where the like name, gender, or anything is specified. Along with this data, you have another one variable where it is mentioned pregnant or non-pregnant. It is a categorical data which you can use for decision making. So what we do is, we consider that particular feature and classify or group the data into pregnant and non-pregnant. It's a kind of binary decision. So this is a this is a kind of an example of data analysis. Here, you develop a model. You develop a model, a binary model, which will be a classification model. This classification model will inform or will predict when it is given a new data, it will predict whether it is a pregnant or non-pregnant. So all our objective is we develop the machine learning model with the past data. The machine learns the future of the data or characteristics of the data. And based on the characteristics of the data, the machine is able to identify or able to give an appropriate solution when it is given a new data. When it is given a new data. So our new user case. Okay. So in the data analysis, as I said, you give some data like age, health records. Yeah. Someone is asking. Venu?
Yeah. Actually, I have a small doubt. You mentioned the data sets contains a pregnant or non-pregnant column, right?
Yes.
Is this the column called the target variable or a label?
Yes,
machine?
it is what called the target variable.
Okay.
Target variable or response variable.
Okay.
Yeah, very good question. Thank you.
Thank you.
Actually, I'm going to explain all these things later because this is just a brief introduction of data analysis.
Okay.
But since you asked, let me explain it further itself. So what we do is when we have the collect the data, there could be plenty of data, tens, hundreds of data. Okay. So what we do is we just go through all data and we'll do some correlation analysis to identify the importance of data or futures. So based on the importance, we develop our own data model. I mean, we develop our own database or data frame.
Okay.
So what we do is we avoid whatever the non-important features, we remove them. We keep only important features. Excuse me. And based on the goal or your target, you are going to develop your model. So in this example, I said, I want to find out whether that particular data or person is pregnant or non-pregnant. So this is the result I want to have. So that is my target. That is my response. Okay. So to achieve this response, there could be other parameters involved to identify whether pregnant or non-pregnant. Other parameters are there. It could be the health record or test result or anything. So we have all this data with us. Okay. Usually what we do is when we want to develop a predictive model, we use the past data. In the past data, all these things we feed to the computer or machine and inform the machine to learn the characteristics features. So once it is read or once it is learned, the machine is able to replicate or it is able to return back the result, the target based on the new information. That is what we are doing in data analysis or data science. Okay.
Okay.
Yeah, perfect. Thank you. Okay. There are many techniques available for solving the problems. Okay. What I said is that a typical example of classification. So for classification, we use classification algorithms. Sometimes, not sometimes, most of the time, we work with regression algorithms, because it all depends on the form of your data or how the data is there. Okay. So for this example, what I gave you has a categorical data. So this categorical data is used to classify your data. So for which we go for classification algorithm. Classification algorithm can be logistics classic regression algorithm, or it can be a tree-based algorithm, okay, random forest, or boosting algorithm, okay, or neural networks, CNN, or anything. So these kind of algorithms are available with us for classification problems. Whereas coming to the other end, the regression problems will be using continuous data mostly. So like continuous data in the sense the quantitative. I'm going to discuss all these things in the following slides. Okay, quantitative data, numbers, numerics. So there are plenty of numerics. The target variable is a numerical variable, and other independent variables also numeric variables. And we develop a model with all this continuous data, for which we go for regressive models. Regressive models, there are plenty of regressive or regression algorithms available, like SVR or anything. So simple linear regressions is also available. So we choose any one of them and then prepare the model accordingly. So for any data science component, the objective is to identify the technique that is very much important. So being the data analyst, you must be good in classifying the data, identifying the data and classifying the data. You must be good in ETL process, okay, and you must be good in descriptive analysis, like visualizing the data, and you must be good in choosing the right algorithm for your model. So for anyone to be data analyst, these are important things you should learn in your career. I mean, in your study. Okay. Usually, several models are developed for solving one particular problem. Maybe you can use different techniques as well. But you will evaluate your models, or you will evaluate the performance of your model, and then finally choose the best model among them. This is very common practice we have. What we do is, when we are given some data, we know what algorithm we need to use, regression algorithm or the classification algorithm, but we go for many classification algorithms, develop different models, and we do testing and find the performance of each model. We keep tune the model. After tuning the model, the result will be better usually, but at some point of time the result will not vary, because when we are trying to fit the model, there are many chances to have overfitting. Sometimes it will go underfitting, or sometimes it will go overfitting. So being the analyst, you have to do this one. It is an iterative process. You do these things and identify which model gives the best result or performance. So after evaluating that one, that is the final model you'll be deploying in your real time. Okay, so this is the general practice. Okay, friends, so far what I did is I just gave a glimpse, basic idea of what is data analysis and how it is being done. Okay, now coming to the next important thing, as I told you, you must be knowing or you must be understanding data, and you must be able to classifying data. If for this, let me introduce different types of data, or I'll talk about data generally. Datum, datum is very common word we use, because data is around us everywhere. Whatever we see, it gives some data. Okay, it all some facts. Okay, the facts may be in the form of numbers or words, or maybe in the image form, or maybe in some script form. It may be of anything. We do not know. Anyone asking? Any you want to ask anything? Okay, all right. I think
No,
it's, yeah, okay. It is previous one. All right. So I continue. So what we need is we need to understand the data. Okay. Understand the form of the data. Okay. The data can be numbers. Very normal, quite normal, right? It can be a number, or it can be a categorical data, a qualitative data. Okay. I said two different words. One is quantitative, another is qualitative. Quantitative means numbers. Maybe if I ask you, if I question you, how many pens you have, you will say 5 pens I have. Okay. If I ask you, what's the temperature now, you will say 30.2. So you will tell me in the form of numbers. That's perfect. The another is categorical data, where if I ask you a gender, you will not say in 1, 2, 0 something. You will say your gender in the form of male, female, like that. So it is a data called categorical data. Okay. Sometimes we work with spatial data like longitude, latitude, or the data related to a particular spatial location. Sometimes we work with temporal data. Temporal data is related to time. Okay. Some data will be very simple data, simple in the sense of only having two different forms, either or, Boolean form. So these are these kind of different forms of data we have in our life. It's around us. Okay. So we collect this data for processing. Okay. So as I'm showing a picture over here, the classification of data. Two important classification is, I mean, in the macro level, it is qualitative and quantitative. Qualitative is a descriptive data. It describes something. For example, if I ask you your blood group, you will say A, O, A plus, A minus, something. If I ask you your occupation, you will say, what's your occupation? I'm an engineer, like this. So this is a qualitative, it's a descriptive type. Okay. Another is a quantitative type. It's a completely measurable numeric values. When I ask you age, you will say 20, 20, 30, 40, something. The qualitative data has subgroups or subtypes like nominal data and ordinal data, whereas quantitative has subtypes called discrete, continuous. Coming to quantitative, I told you an example already. When I ask you the age, you will say 20, 30. You will never say 20.1. So it has a gap. Okay, so it's called a discrete data, 20, 30. But when I ask your salary, you will say something 0.20, something 0.30, something. You will say in the form of continuous data. Okay, so these are two different types of quantitative data. Coming to qualitative data, we have nominal data and ordinal data. Ordinal data will have some order. Nominal data doesn't have order. For example, the nominal data or categorical data with no natural order. Okay, blood type, there is no natural order. Gender, there is no natural order. You can say to me male, female, or female, male. Any order you can place, you can use. But when I'm asking like score, okay, when you are giving your feedback, your satisfaction ranking, what you do is you will inform or you will express in the form of 0 to 10, 0 to 10. So it is it will be in some order, 0 to 10, low, medium, high, something like that. So this type of data are called ordinal data. So in terms of qualitative, nominal, ordinal. in quantitative, discrete, continuous. Fine. Where do we get data? As I told you, data is around us everywhere. We get the data by observations. We get the data by test. We get the data by experiments or analysis. We get the data from surveys. Most of the business list, we use surveys. Surveys, we do quantitative survey, qualitative survey. Quantitative survey in the sense sometimes we prepare some forms, we pass to the customers, collect the data. Sometimes we interview the people. We use videos, we use audios. Okay, we interview the people and collect the data. So the data collection can be qualitative mode or quantitative mode. Sometimes we observe. We don't ask the people to tell us anything. We observe the activity, we observe what is going on there, and then record the data accordingly. So that is a kind of observation. Or we sometimes do some experiments. Based on the experiments, we get some data. That's the other way of collecting the data. So whatever the form you are adopting, you will have the data either in the form of qualitative or quantitative. Sometimes you can classify your data based on the collection structure. Collection structure in the sense, it could be like cross-sectional data. Cross-sectional data means if you are collecting the data for a particular time period. For example, there are many movies released in 2026. You are collecting the budget of each movie and the collection of each movie. Okay, so if you are organizing this kind of data, it's a cross-sectional data which explains or describes the movies released in 2026, a particular period of time. The same thing, similar to that one, but it's the other way. If you are collecting one variable across several time intervals, it is called time series data. This time series data is very much important for industrial applications. For example, a motor is running. I want to monitor the variables involved in the working of motor. Okay, so the motor takes some input, voltage, current, and it rotating. Okay, it's running at some speed. So I use some sensor to observe the speed of my motor. One, I observe the vibration of motor. I use some sensor to observe vibration of the motor for a period of time. For time intervals, maybe I work in first week, second week, third week, like this. So I'll collect all this data, put them together for analysis. This kind of data is called time series data. Sometimes we work with many variables, okay, over a period of time. That's called panel data. Okay, in the sense you may be interested to see the GDP of different countries in different years, like GDP of New Zealand in 2025 and 2026, GDP of Australia in 2025 and 2026. Like this, if you arrange the data and use it for the analysis, it's called a panel data. So the data can be of any form. So that's why I just introduced the key concept of data here. Okay, when you look at the facet of data, it could be the structural facet, temporal facet, or spatial facet. In the sense, what I try to say here is, if you are collecting the data from some location, okay, it's a location related data. So it has a facet of space, right? So it's a spatial facet. Okay. In case if you are collecting the data over a period of time, timestamp based, so it is called time series data. And all other data what we discussed so far, okay, continuous data and whatever it is, okay, related to experiment or related to test or related to observation, whatever it is, it could have a structural facet. The structural facet in the sense there are many structural facet as well. Sometimes the data may be completely fully structured data. Sometimes it will be semi-structured data. Sometimes it will be unstructured data. I'll give an example here. You have a QR code. Okay, the QR code, it is a data, but it is not in the form of number. It is not in the form of a categorical data. It is a image. It is what called unstructured data. Okay, the video that you are observing or collecting during an interview, it's unstructured data. The text message, email message that we are getting from someone is in the form of unstructured data. So we work with unstructured data sometimes. We work with completely fully structured data, like what I said earlier. We do experiments, we collect the data perfectly, or arrange them in the rows and columns and make them as a table. It's perfect. It is called a structured data. Another form is semi-structured data, where you will see all rows will not have the same number of data. Some rows will have 4 data, some rows will have 2 data, some will have 8 data. So it is not uniform over there. It is called a semi-structured data, like JSON or XML data. So what I try to say here is data is important. We have plenty of data around us. We collect the data before we go for testing or before we go for analysis, and we understand what type of data it is, what form of data it is, and what model or what test we have to carry out with this data. So our decision is completely based on the type of the data that we are collecting. Okay, friends, it's a purely a key concept I discussed with you last few minutes. Is there anything you want to ask me? Do you have anything to question me?
Not really, sir.
Okay,
All
perfect.
good. Thank
Yeah.
you.
All good. So we take
Just
some.
one doubt.
Yeah.
Can you please tell me, sorry, I'm a bit late, but I just want to know what is the difference between data science and data analysis?
Okay, data science, data analysis is a part of data science. You know, it's a holistic view of thing, right? Data science, data analysis is a part of it, right? We do analysis with the data. Yeah, it's
so can we put in this way, like
yeah.
analyze your data and develop a model and predict and give a prediction is called a data science, the whole process?
Yeah, the whole thing, a holistic thing, holistic view of your data analysis is called a data science. Okay.
Yeah.
For example, if I question you, you'll say you say science, right? Science comprises of many things, many tasks or many activities involved. Okay, so data analysis is a part of it. You are doing only analysis. Okay, so it could be analysis in the sense it doesn't not necessary to do testing. Okay, statistical testing. Without statistical testing, you can go for something else. We have many tasks, not necessary to complete all tasks. You can choose the task what you require for your own objective, for your own goal. You can choose some task and you can complete it. Okay, so data analysis is purely I mean, if you ask me what is data analysis is analyzing the data. Okay, whereas you will follow the procedure or the steps involved in analyzing the data. Like collection of data, extraction of the data, transforming of the data, loading of the data, visualization of the data, preparing the model, okay, preparing the model and deploying the model. So this is the sequence you will be following. There, you can avoid anything, depends on the requirement of your company or requirement of your particular institution. You get me?
Yeah, thank you.
Okay. All good. Let me move to this in-class activity. Please get ready. You're the one going to answer me. We take the first one. Can you tell me the facet of, it's all about the healthcare data, okay? The first one, electronic healthcare records, lab results, imaging data, unstructured notes.
It's an unstructured data, maybe structural facets.
It's I'm asking about facet, right? Structured facet.
Structural facet, yeah.
Correct. Next, patient ID, admission,
I think
date.
same.
Okay.
Structured facet.
Any other answer? We say this descriptive, it's a structural facet, but particularly descriptive type.
Okay.
In the structural itself, it could be quantitative based or descriptive based. Okay, this one is a descriptive structural data.
And the third one is quantitative. Yeah.
Quantitative structured data.
And the fourth is qualitative.
Yes, qualitative, exactly.
And the fourth
Next
is temporal.
Treatment timelines, appointment dates, decision progression. Okay, temporal.
Temporal.
This is the spatial.
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 Yeah, spatial.
Spatial.
6-1
Yeah.
spatial.
Spatial. Yeah. Because it is related to patient location, hospital region, disease spread mapping, all related to spatial. So we call that is spatial data.
And there is behavioral.
Yes, it is all behavioral. Yes. CT image.
Semantic.
Descriptive.
It's all clinical images.
It's a semantic.
Unstructured semantic. Yes.
Yeah. And this is the governance, I think.
It's all related to management. It's all related to ethical privacy governance.
Yeah. And this is the life cycle, right?
Yeah, it is continuous. It's the data related to continuous process from the symptom onset, diagnosis, treatment, recovery, accrual. It's all like that. It's a period of time you are taking. It may be of one person or many persons. Okay, so it's related to life cycle. Thank you. It's the one I'm showing here is related to finance data. Transaction logs, account statements, XML, JSON fields, all this
Structural.
semi-structured.
Semi-structural.
Yeah, because XML is semi-structured.
But your answer is structural, sir.
Not exactly
The first
structured,
one.
semi-structured. Not exactly structured, semi-structural. Because why we get structural here is I put structural is it's all not only on XML JSON, we have an account statement as well. Account statement would be structural. Whereas XML feeds, we should see how the feeds is. Usually XML, the data will be in semi-structural form. Next is account type, transaction category, credit rating, everything is descriptive type. Next, account balance, interest rate, Very clear, right? Account
Discrete.
balance. Account balance will be number, right? Interest rate will be
Quantitative.
number. Yes,
Quantitative.
it's a quantitative. It's all numbers. Numbers, continuous numbers, mostly. Then investment risk level, customer satisfaction categories. Customer satisfaction category,
Qualitative level.
yes. You collect customer satisfaction. Okay. Satisfaction, it could be in the form of ordinal value. Okay, ordinal, quantitative ordinal value. Okay, investment risk level, it is risk level, it's from 0 to 10 or 0 to 5. You can say, you can refer it in some scale. Okay, it's a scale based one. So scale based data,
You mean to say categories and labels, right?
yes. Yes, that's what I try to say. You can particularize the data. Qualitative, quantitative is a macro level. After you confirm the macro level, you can go in depth to particularize it. Stock market trend. Okay, this is just temporal based, time based. Okay, timestamps. Next, branch locations, geographic, market segmentations. It's all spatials. Spending patterns, fraud detections from transaction behaviors. Spending patterns. That means
Time.
you are listening. Yeah, you are listening the pattern. The customer is spending the money. Okay, it's a kind of behavioral data, because you are finding the trend of spending the money. Then fraud transaction from the transaction behavior. It's all behavior based. Okay, it's of course qualitative included, but it is behavioral based data. Next. Industry classification standards. Semantic. Next is compliance, access controls. Yeah, governance. It's all about governance, ethical,
the last one
privacy.
is the life cycle.
Correct. All right, all good. Thanks for answering. Let's move to, so we understand what is data, okay, and how it behaves. So next process would be understanding the process or the steps involved in extraction, transform, loading, all this. Okay, so this kind of process is called the data wrangling process. Data wrangling process includes data acquisition, I mean collection of data. So you collect from various sources. After collecting various sources, you bring them to a central location. Then you will thoroughly check the data. Thoroughly check the data means you have to clean the data. You have to identify the missed data. You have to identify duplicated data. So all the things are to be corrected out and make your data consistent and accurate. That's very much important. I'm not going to teach you how the data cleaning process is to be done, okay, or what method we do, but I can give you an example here. Okay, it's a different. It's not included in our discussion or the class, but I can give you an example for you. Like when we look at the data, particular data. Okay, let us take amount spent by customers. Let us take. Okay, spending amount. Spending amount, we have the number for all customers except one customer. Spending amount is missed out. Okay, I mean it is missed out when the company collects or some way, some technical issue. Because of that one, it is missed out. So you don't have, being the data analyst, you see that there is a gap in the particular cell. So you have to replace it or you have to add something into it. What do we do? So what we can do is there are many possibilities. One possibility I tell you, we take a mean of the data. We take mean of the data. So what I'm telling is, just a moment. What I'm telling is, suppose when I have the data spending amount, okay, spending amount 50, 20, 30, 40, something like that. One is missed out, okay, 40 here. So I just take the average of it, mean of it. So 50, 70, 100, 140, 180. So 180 over 1, 2, 3, 4, 5, 6 data there. So 180 over 6 will be 30. So I will replace here by 30. That is what I do. So I just find a mean and replace the empty space by this mean value. It's a kind of, it is not accurate. It's an approximation. But this kind of thing we do in data analysis. Okay. So that's why I told you, I in the beginning of the class itself, I told you, you must know the statistical analysis, the test, all this. So that is also important for you. So being the data analyst, you will do all these things. Okay. So coming to the class, so we just do some cleaning process. We replace the duplicated data, missed data, all these things, and make our data clean, accurate, and consistent. Then we go for data exploration. So data exploration is the way you will understand the structure of your data or trend of your data. The trend of your data. So you do some kind of visualization and see how the content is. So based on that, then we go for transformation. In the transformation, there are many things we need to do in the transformations, like data standardization, data integration, many things there. Standardization is very much important. For example, when we have plenty of futures or plenty of data, all data will not be in the standard form. Like, for example, I'm telling, one may be like this, 20 July 2026. Another may be like this. Another may be 7/20/26. So data might have been collected in different forms. But when you are taking this data to your process, your analysis, all these data must be in a standard form. So that is very much important. So that is the thing you will do in the data transformations. So you just make everything similar or common or standard. So after we do this data cleaning, data exploration, data transformations, we load the data into the system. So data into the maybe your cloud, data cloud, data lake, or anything, any place where you want to do further processing. So this is a simple. So for ETL, we have many tools. I just list here some tools that we are using for ETL process. Okay, Azure, sorry. Yeah, Azure, right? So there are plenty of tools available for ETL process. For data cleaning, we have plenty of tools. Okay, maybe you can do data cleaning with the Excel itself. If you are very comfortable working with the Excel, you can use just the Excel, or you can go for SQL as well sometimes. I will explain this one. I will give you an example why SQL is important. In the data transformation, you have to apply some rules over there to extract the data. For example, you have 1,000 data with you, but you don't want to use all 1,000 data and want to use only the data matching your requirement. So for example, I want to work with only the customers who have transacted more than $1,000 in last month. So I just write a query there. I just extract the data from the database and work with only those data. So that kind of transformation you have to do. So you can use any software for this one. These are very commonly used data cleaning software, Excel, SQL, Pandas, Python Pandas also is a good software we use to. In Pandas, we have many functions. With that functions, we can create queries and we can filter the data and can take them for analysis. If you are looking for visualization, Tableau, Power BI, Looker Studio, there are many tools available. Okay, Matplotlib is
Natarajan,
yeah.
I have one question. How do you decide which data should be filtered out, and
That's based on the goal. That's what I said. So you will define the goal first. So based on the goal only, you are going to do all other tasks.
Okay.
For example, if you are working for ANZ, the company asking you to do data analysis on the customers who transacted the money more than $10,000 during the particular period of time. So it is an objective, right? So once you are given the objective, then you will do that. You just write the query, filter the data from the database. Then that particular data is the one you will be doing all this kind of task, cleaning, visualization, everything.
Okay.
Coming to this data visualization tool, Tableau is very famous one. Power BI, Microsoft one. Okay, Looker Studio, ClickSense, Matplotlib, Seaborn, Plotly, all these three libraries are very good libraries we use in Pythons. Actually, I'll be touching this in after 4th week. I'll be touching all these things. Okay, Matplotlib you can use for static graphs. Static graphs means bar chart. If you want to make a bar chart, a stacked bar chart, okay, pie chart, this library is useful. It's all for the, it's in the fundamental Python library. It is to create static pictures, static charts. Next one, Seaborn. Seaborn is, it's a statistical visualization library. Statistical visualization library. So what it does is, we do statistical analysis and then we get the output, we visualize the output from the statistical analysis. Like you may be interested to have a histogram, okay, histogram, or you may be interested to have some kind of plot, okay, heat map plot based on the statistical analysis. So that is what we do with the Seaborn. Plotly is a very good Python visualization library, which is used to create dynamic plots, dynamic charts. Okay, you can make graph. You can like when you are pointing, when you are moving your mouse to a particular place, the graph will zoom that place and show you you can visualize a zoomed object. That's that kind of dynamic animations you can do with Plotly. Okay. So, and coming to data wrangling, which comprises of data cleaning. So these are some software we can use. Then for the programming, you all know programming languages, Python, SQL, Java, JavaScript, all this we use. We have some data quality tools to monitor whether data is accurate, complete, consistent. Okay, so to ensure the quality of our data, we can use some other tools, like you can go for Carlo analysis, or you can use SAP data quality tool, which will confirm your data quality. So various tools available already, but not necessary to work with all tools. You set your goal, you set your specific objective, the career where you want to move in. Based on that, you just prepare yourself with that particular tool. That's enough. Okay. So I just give you some use case here for use case and the tool that suits for this use case. In case if you are aiming to have business dashboards in the sense you want to visualize your data in beautiful graphical form, okay, for which you can go for Microsoft Power BI. Microsoft Power BI gives you complete tax formulas. Okay, you can make interactive reports with the Microsoft Power BI. In case if you are if you don't want to learn Microsoft Power BI and want to stick with the Python itself, you can go for Plotly. It's up to you. Then for interactive dashboards, but for the drag and drop interfaces, real-time collaborations, maps, you can go for Tableau. If you are aiming for free cloud reporting, that means you want to connect with the Google services, you want to share your data with other services, real-time data you want to handle. So you can go for Looker Studio or some kind of tool. If you are aiming for infographics and storytelling with some maps, timelines, surveys, you can go for Flourish or what you said, Stamina, anything. There are plenty of tools. It's up to you. Okay. Quick charts, reports. If you want to prepare, even charts and reports, you can prepare in Excel itself, of course. Okay. But if you want to present it to the social media, infogram is one of the tools you can use. I'm just giving an example here, but not necessary to follow my example. You can take any tool as you like. For journalism and publishing, okay, with no coding experience, you can go for Data Wrapper. So I just give a bit of the different libraries and the plots over here. Okay. For this use case, like you want to plot or see the graphs based on your statistical output, you can go for Seaborn. Okay. If you want to make interactive plot and you want to hover the tools and the zoom web dashboards, then can you answer what would be the right one to use, or what do you prefer?
Tableau.
You want Tableau? Okay. What else?
No.
You want to hover? If you are stick to your Python itself, what would be the right one to use?
Plotly.
Plotly. Exactly.
Yeah.
Exactly. Plotly is a better one to use. Or programming, if you are working with geographical data, okay, like the whoever is working with the GIS, okay, geographical information systems, like maps, like all our councils, New Zealand councils, all biodiversity management institutions are using GIS systems. And if you want to analyze the data based on the graphics or the pictures that you observe, then R programming is one of the things you can use. Okay, it's a R statistical graphics. In the R statistical graphics, we have many tools. One of the library is called ggplot2. That ggplot2 we can use for printing or visualizing the data. Okay, it is particularly for R programming, ggplot2. I use ggplot2 for my analysis. Recently, I completed one of my research activities based on biodiversity management, where what I did is I just collected the images using the thermal cameras. I set up thermal cameras in different locations inside the forest and monitor the movement of possum. You know possum animal, right? So I just observe the movement of possums activities, and then I did analysis with them. That was my the last project. Okay, recently I completed that project where I used R statistical graphics as well. I developed GLM model. Okay, GLM model based on the data what I observed in two different sites, forest sites. Next is Python declarative plotting. If you're clean code, pandas friendly, it's Altair. JavaScript web visualization, D3JS. Excuse me. Python web ready visualizations, Bo. I just giving here some examples only. Friends, this is not a concrete one you should follow. You can use, you can prefer whichever is very easy to work with, you just to choose it. And like I told you, the geographical data, large data sets, okay. Kepler GL is a library we can use for network GP, for uncommon chart types, okay, from the open source raw graphs, web-based JS nodes observable. So these few tools available in the market. All good. Friends, I just so far what I did is I explain you what is data, how to classify data. Okay, so you know you are able to understand and classify the data, and you know the process that we need to take up, okay, before we do some analysis. Now the time to learn what are different analysis we have. There are three different analysis in conceptual side. One is descriptive analysis, which we must do. Always we do this descriptive analysis. Okay. The descriptive analysis is the one we do to visualize past data. So we just visualize the trend of the data, or we try to understand the data, but all these data are collected in the past. So what happened? Okay. So we just do summarize the historical data, we do summarize the patterns, we do prepare the reports, okay, we do identify the correlation between the variables, and all these things we do in the descriptive analysis. Mostly you will prepare the static graphs. Mostly we do static graphs like bar chart, pie chart, all this. Okay, but if you want to make descriptive analysis more interactive and want to build dashboard for this one, better you go for Power BI. So that will give you the rooms or space for interactive analysis. Then after completing descriptive analysis, we move to predictive analysis. Predictive analysis is a kind of model we develop. Okay, as someone questioned me, the role of data analyst is not only developing the predictive model, it could be anything. That's what I said. There are plenty of tasks we have in data science. So you can choose anything. Predictive analysis or developing predictive model is one of the tasks we do. If, for example, if someone already had completed ETL process, everything, and then pass you the complete clean database, now you, being the data analyst, you can take up the predictive analysis with the complete cleaned data. You are not data engineer. You understand what I said here? Someone asked question me earlier, right? So you are not data engineer. So data engineer is part of data science. Data analyst is also a part of data science. So there are different roles. There are different tasks carried out by different people. So predictive analysis people, or the predictive analyst, what he does is, after understanding the variability, after understanding the trend of the data with past data, he will try to feed the futures of the data through a machine. So he is developing a machine learning model now. So this machine learning model is otherwise called predictive model, is going to predict the target variable. It is going to not target variable. It is going to predict the independent variables based on the target that you are feeding. I repeat now. Okay. For example, just a moment. What I try to say here is, okay, I have customer name. Okay. Customer name, customer account number, and amount spent. Okay. Amount spent. Okay. Date or something. So I have collected all this data. All right. So I want and other maybe I put another variable like the area. I mean the amount spent for what purpose. Okay. I just put here purpose. Just for the easy understanding, I'm writing this example. Okay. So he spent $50 for grocery, $20 for books, $30 for maybe entertainment, like this. So I have different data here, the purpose categorical data, and I have the numerical data corresponding to this. Okay. And other things also there, customer name, account number, and the date, everything there. So now being the data analyst, you can fix your target variable. The target variable is the amount spent. Okay, amount spent for grocery. Okay, and also on the particular period of time, the season. Maybe you can fix a window over there. Window over there in the sense maybe the festival time or something. Okay, so you have plenty of data, many records, many customers data. Okay, it's the same customer repeated transaction on a window period of time. So what you are doing is you are just feeding all these things to your computer, your machine, to understand the future of it, learn the amount spent during the festive season, and the particular purpose. So it learns everything. Then later, what you can do is you can ask your machine to predict what mostly the customer will buy during this festive season. So the predictive model will explain you exactly what is going to be bought during this particular festive season, and how much would be the average money the customers will spend during this festive season. So this kind of predictions you can do. So this is what exactly the companies or business people want. Okay. Am I okay reaching you?
Natarajan?
Yeah.
What is the additional skills do we need to move from descriptive analytics to predictive and prospective analytics?
Okay. Your skill, there is no particular skill you need. Okay. These all are in the Python library itself. Okay. If you are a data engineer, you will restrict yourself with ETL process. Okay. But if you are a data analyst, you will move to developing the models. So when you are planning to develop models, you must know the coding or the Python, the codes, okay, to develop a model that is perfect for your objective. Okay, so what you do is you will that is what I told you in the beginning itself. You must select the right algorithm based on the data what you have. So you will select the algorithm, Then you will write the code to develop the model. Then we will test the model. You will see the performance of your model. Based on the model, you will deploy it. Based on the performance, you will deploy it later.
Okay.
So
Okay, thank you.
it's not all related to Python coding. So that's why what we decided, me and Indra decided to teach you is we restrict ourselves with the descriptive analysis this session. So after this session, once you are familiar with this one, you can move to predictive model. That will be the following, maybe after few months. We
Okay.
do it next. Okay, coming to this descriptive analysis and predictive analysis. Okay, predictive analysis is used when organization have stronger data and modeling capability. They go for predictive analysis. And but descriptive analysis is very common. It is very much important for any process. Okay, but the higher one is the prescriptive analysis, where you will be introducing optimization technique like a linear programming. So this will be giving you the optimized output. Predictive analysis is the mid of it. It is not. It may not be optimum target, optimum response. But if you are very particular of optimum response, then you will go for prescriptive analysis. So that means it is going to prescribe you. Okay. So like I made a slide over here to explain what is descriptive analysis. It's the simplest first thing you need to do in your data analysis. All you are doing is just observing the trend of the data and plotting your data in different graphs. Okay, it's all about data visualization. Okay, like static graphs, what I showed here: bar chart, histogram, box plot, scatter plot, pie chart, and so you can use any tool as you like. Then you do these kind of things, and then you understand the trend of your data. Once you understand, then you go for the predictive analysis and you try to teach your machine. Okay, there is a process we need to follow. Then with the past data, the machine understands, machine learns, and then machine is trying to replicate. It is going to predict the target or response based on the new scenario. Whatever the new scenario, new data you are giving in, unseen data, for the unseen data, the predictive model will respond to you. This is the process we follow. Okay, as I told you, is same thing. Raw data we collect, clean, explore, we develop model, evaluate model, then we deploy the model. Okay, these are few examples I put here. The various companies who develop predictive models for their own business improvement. Okay, business value. Okay, maybe I just take one example here. The HP, they develop employee flight risk score. So they develop the model, predictive model for the flight risk score. Okay, same thing. Google has developed a predictive model to estimate flu spread. Okay, H1N1 flu spread. So like this, different predictive models developed by different companies across the globe. Coming to the prescriptive analysis is something top of it, where you'll be using some optimization algorithms so that the prescriptive model can give you the optimum solution for your problem. Okay, so it can be used for taking the right decision. Okay, it can be there could be many alternatives, but you can choose the right one based on the optimum solution. So all this, for this prescriptive analysis, we need to include the operation research technique. There are plenty of operation research technique, particularly linear programming is very common to use. For example, few companies already introduced this kind of prescriptive analysis. I just put here, I listed here few companies who develop prescriptive analysis. I take one example here, the Coca-Cola Enterprises. They develop a prescriptive analysis. Okay, to meet several objectives like improved customer satisfaction, optimal asset utilization, and so with this one, they saved about 54 million USD, and also improved the customer satisfaction based on this prescriptive analysis model. Okay, like this, Samsung developed, HP developed, and many companies developed. Coming to the comparisons, okay, predictive is simple form. Okay, it's prediction done, but prescriptive giving you optimum solution where you are using linear programming, integer programming, multi-criteria decision making. Okay, MCD. Okay, and you may use any kind of optimization algorithm to get even meta heuristic algorithms like TLBO, anything you can use to get the solution. Whereas for the predictive, we use regression algorithms. Regression algorithm, if it is a regressive data, or we use classification algorithms, as I told you in the beginning of the class. Okay, with this one, the content for the day is complete. Okay, we have 2 more minutes to finish. In case if you have any queries or any doubts, please come up. After your queries, I will just conclude my remark.
Which IDE will be used to learn this Python course on this?
ID, in the sense.
IDE, IDLE. I think
IDE,
you have
okay. IDLE, okay. IDLE, okay. I will introduce IDLE in week 3. Okay. It's up to you what IDLE you want to use, right? You can download PyCharm from JetBrains. You can use PyCharm, or if you want to do it online, you can go for Google Colab. Okay, Google Colab, you are working in the cloud. Okay, Google Colab. Anything you can use. So you can have your own IDLE. I mean, download it. Python 1,
even
own
VS
Python
Code
1
as
or
well, right?
JetBrains, private third-party one, anything you can use. I will introduce all this in the week 3. Yeah, thank you.
So,
Any other questions?
do you recommend anything for the beginners to learn?
I think Databricks has AI feature. It has free edition, which is it's good to start with.
Okay, it's up to you. It's up to you. Any interpreter is okay. Even what I do is when I am teaching Python code to undergraduate students, I don't ask them to download anything, because it is not for computer science students. It is for mechatronics students. So what I do is I just ask them to use online interpreter. It's simple thing. But for your case, it's different. You just go for something standard one. Someone asks other question. Someone ask other question.
I think you already answered it.
Oh, okay.
Thank you.
Sweta. Okay, any other questions?
All good.
Okay, I also saved a link where the materials will be imported. Will be shared with all of you. And if you haven't joined the WhatsApp group, please join, because it's easy to communicate on WhatsApp group. Because I tried to send bulk email, for some it must have gone into the spam folder, because I received it in my spam folder. So I was not sure. So we were trying to frantically add people to WhatsApp group. But then we thought, okay, let's leave it because it's last minute. And then I sent the message of joining in the WhatsApp group. So kindly check your WhatsApp group, or check your emails in spam. And I got a couple of LinkedIn messages as well to get the link. So yeah,
Is it the video is also available in the same material link, or it will be different link shared?
No,
after
I'll
this?
post it in the WhatsApp group.
Okay, thank you.
Yeah. I'll make a playlist. Okay, I think that we can conclude. Do you have any further questions, or can we conclude? Yes. Okay.
Okay. If no more questions, I just conclude. Today is just a fundamental discussion on fundamentals of data analysis. And next week, we will be discussing about statistical analysis. So I will give you some, I will show you the way what we can do. I mean, the way we can do statistical analysis in Excel. Okay, simple form. It's not Python, because I'll be introducing Python following week. So Excel I'll use to show you how the t-test can be conducted, ANOVA can be conducted. I just give you a overall idea of the t-test and how the t-test result is to be interpreted. So that we will see in next following week. Okay. Thank you, everyone.
Thank you, Ilango. We are
Thank you.
really
Thank you
fortunate
very
to have you.
Thank you.
much.
Thank you,
Thank
Natarajan.
you, everyone. Ilango.
Thank
Thank
you.
you.
Thank you. Bye.
Bye bye.